That well-known question, the one we may never be able to answer. This is very frustrating, I know, but we like to push the limits, don't we? So far, we've managed to find answers to many questions we once thought were impossible. So let's ask that question again and take a look at what we know. Yes, what existed before the Big Bang. This is extremely difficult. It's like asking a very simple question, actually not the same, but think about it. What would happen if we weren't conscious, if we weren't thinking beings? We don't know. Because we have science, we have the consciousness to ask this question. It's another impossible question. Anyway, let's look at what we do know. First of all, even if we don't have much information about what came before, we know quite a lot about how it started. We've talked about this many times, but to summarize what we know that the observable universe was once much smaller and hotter, and that it continues to expand. We also know approximately when this expansion began, about 13.77 billion years ago. For about 50 years, we've also been aware of the cosmic microwave background radiation. This is essentially the first photograph of the universe's history. In fact, this image is the radiation left over from the Big Bang, and it appeared when the universe was still a baby, around 400,000 years old. That corresponds to about 0.003% of the universe's current age. If we compare it to a human lifespan, it's like taking a photo about 10 hours after birth. Of course, even though what we can observe only goes back 400,000 years, we actually know quite a lot about what happened before that. In particle accelerators like the Large Hadron Collider, we can understand why the universe was so hot earlier. For example, when we collide lead nuclei, we observe temperatures of around 7 trillion degrees. Thanks to this, we can study what the universe was like when it was only a trillionth of a second old. Yes, these are the facts we have. We have evidence-based knowledge about what the universe was like when it was around 10 seconds old. Just thinking about that for a second, it's truly incredible, an example of humanity's limitless curiosity. Now let's come to the before, to the 0 point. Let's say this clearly. We know absolutely nothing about anything before that moment. It's all speculation. Unless there is an incredible breakthrough in physics, we may never know, and that's certain. Science cannot tell us anything about that time, at least not with evidence. And that's not a problem. Not knowing isn't shameful. The real problem is claiming to know when you actually don't. That being said, there are some ideas, and we'll talk about them. First, the observable universe was obviously much smaller than it is now. But if we include the unobservable universe, the most distant regions we can never see, we think the universe is at least 500 times larger than what we can observe. This size is beyond comprehension, and describing the universe in 3 dimensions is difficult. So let's simplify it to a one-dimensional view. If we place ourselves at the center of the observable universe and represent it as a line, we can imagine that the rest of the universe is at least as large as a circle surrounding that line. In other words, compared to the observable universe, the whole universe is at least that large and likely much, much larger. It could even be infinite. But focusing only on what we can observe, we see that it's actually very small. At the beginning of the universe, the region we can now observe was extremely small, but not zero. This is often misunderstood. It's not zero, just very small. So what did the universe look like in that tiny region? The truth is, the physical laws we know did not exist back then, so it's impossible to describe what it looked like. Perhaps it was like spacetime today, where matter and energy constantly appear and disappear. There's also a common misconception about the Big Bang. In such extremely dense conditions, where everything is compressed into a tiny space, it's often thought that time stops due to near-infinite gravity. But if we somehow existed at that point, assuming time even existed, time would feel normal to us. An outside observer might see us as frozen in time, but that's relativity. Also, it's thought that spacetime itself was created with the Big Bang. But at a point where all physical laws break down, even saying that time equals zero becomes questionable. In other words, trying to define that moment, the before and the very first instant, with today's knowledge will likely lead us to wrong conclusions. Still, let's look at some ideas about what might have existed before the Big Bang. The first idea suggests that before expansion, the universe existed in a compressed state for an infinite amount of time, like a stretched spring. Then, due to something like a quantum fluctuation, it transitioned into expansion. This is similar to how particles move from a stable state to an unstable one. According to this idea, there was no beginning. It was always like that until something happened. Other ideas propose a more dynamic pre-Big Bang universe. To understand these, we need to think beyond three spatial dimensions and one time dimension. There are theories that suggest additional dimensions. If these dimensions exist, there could be other universes we cannot interact with. To simplify, we think we live in three dimensions, but compared to birds, even our experience is limited. We mostly live on a two-dimensional surface. Birds experience three dimensions more fully. If higher dimensions exist, perhaps our universe always existed, but in another dimension. The Big Bang might have been a transition into our current one. The last idea is eternal expansion, or a multiverse-like concept. In this view, the universe is like bubbles in water, forming, merging, and disappearing. Our universe could be just one bubble within a much larger structure, with countless others existing alongside it. Of course, none of these ideas can currently be proven with our level of knowledge and technology. That's why they should be treated as speculation, not established theory. When we can't even be sure what time is at that point, claiming certainty is extremely bold. So what are scientists doing to solve this? The main goal is to reach higher energies. To understand those early moments, we need particle accelerators far beyond what we have today. There are plans for future colliders even larger than the Large Hadron Collider, and perhaps they will help us find answers. But we should also be ready for completely new discoveries, things that could change everything we think we know. Or maybe some ideas that once sounded absurd will turn out to be correct. In short, science cannot give a definitive answer to this question, and those who claim they can are, simply put, wrong. Yes, we know a lot. We have a picture of what happened up to 10.3 seconds after the Big Bang, but we don't know everything. And that's the beauty of science. It clearly shows us what we don't know. I hope that even if we can't find all the answers, we will witness some of them in our lifetime. And I'll end by saying that I have a somewhat utopian belief. Humanity's only real pursuit should be the search for meaning.
Thanks so much for watching my video. I really appreciate you taking the time to be here. If you enjoyed it, don't forget to leave a like and consider subscribing. It really helps the channel grow and keeps me motivated to create more content like this. Also, if you want to be notified right away whenever I upload a new video, make sure to turn on the notification bell so you don't miss anything. Thanks again for your support, and I'll see you in the next video.